Hi everyone, we are from Group 5. Today, I am going to introduce a weapon that contains no explosive, traveling 7 times or so times the speed of sound, which can rip through steel or concrete, destroying anything in its path. Sound interesting, right? My name is Nicole Chee alias Robin James with metric number 161184. I am the presenter of this group.
My name is Lim Ying Ying with metric number 163460 and I am the scriptwriter of this group.
My name is Angellyn with metric number 161161 and I am the editor of this group.
This weapon is known as an electromagnetic railgun, which is the topic of our group.
Prime, make something of yourself. He's pissed.
So, what is an electromagnetic railgun? Let me give you a brief introduction to this weapon. Electromagnetic railgun were developed for the purpose of attacking ships at long distance and intercepting missiles. It's been a long time since the concept of a railgun appeared. Now, let's look at how an electromagnetic railgun fires. The theory of how an electromagnetic railgun works is very easy to understand. Railguns use electromagnetism to propel a conductive armature housing the projectile. The building blocks of a railgun are a pair of parallel conducting rails. One acts as a positive and the other as negative conductor and a sliding armature. The two parallel rods are connected to a power source. These two rods can be considered as the weapon's barrel. Connecting these two rods and completing the circuit is the armature. As the current passes through the rails, it generates a magnetic field. The interaction of these perpendicular currents through the magnetic field produces something called the Lorentz force. Lorentz force is the force which is exerted by a magnetic field on a moving electric charge. The Lorentz force is directed perpendicularly to the magnetic field and to the direction of the current flowing across the armature. Fleming's left-hand rule can be used to remember the direction of this force. In the case of the railgun, this force is what pushes the projectile through the barrel and downrange. Here are some problems that need to be overcome to make this a serious weapon system. First and foremost, the same force that is applied to the armature also acts on the parallel rails. Quite literally, every time the weapon system is fired, the gun is actively trying to tear itself apart. Moreover, the heat generated during each shot is so immense it is melting the rails. This can be seen during test fire drills with prototype railgun systems. That discharge you see behind the projectile is not the result of explosive propulsion, but a result of the resistive electric heating created by the huge current running through the rails and the frictional force between the armature and the rail, causing the rails to melt and shed material during each shot, causing more damage to the rail. Next, and possibly the most obvious limitation to the railgun design is the power supply. For this weapon to ever be introduced to the service, it would have been to pair with a power source capable of providing the 25 megawatts needed to fire it. This is equivalent to the electricity used by about 20,000 households. Even a 32 megajoule railgun requires at least 15 to 30 megawatt of power on board power generation, which is much more than these classes of ships generate. In anticipation of the power demand from these weapons, the Navy's brand new Zomwat-class destroyer can generate up to 78 megawatt of power, of which it only needs 20 megawatt to operate. That means it can have lasers and railguns that throw up to 58 megawatt of power. While this technology is currently being funded by the military, it has far-reaching potential for other industries. They have been suggested as means of protecting the Earth from asteroids with huge versions in orbit to destroy or change the direction of incoming asteroids. Launching a satellite like this could also be made drastically cheaper too if we can deliver the materials to orbit with nothing more than the force of a magnetic field in parts on a moving electric charge. That's the end of this video.
Thank you for watching!